Hello, I'm Smjk.
And I'm Taiwan N.
And we are from
Smjk Chong. Today we will be carrying out 4 experiments about water.
And we're going to be explaining the concepts behind these experiments.
So the first experiment we are going to carry out is the floating paper clips.
Most importantly, it will be the paper clip
and we need a cup of water
and a fork.
First, we will put the paper clip into the cup through normal means. And as you can see, the paper clip will sink into the water. However, if we use a fork, the results will be different. Place the paper clip gently into the water. Ta-da! The paper clip now floats on the water.
Paper clips sink in water because they are heavier or more dense than water. Gravity pulls harder on denser objects. The water pushes back up on the paper clip against gravity, but not with enough force to keep the paper clip afloat. So how is it possible for the paper clip to float? For this thing, scientists call surface tension. The surface of water has what is known as surface tension, a bit like a skin. The particles or molecules that make up water are attracted to each other in all directions and, just like good friends, stick tight together. A fork helps you lower the paper clips onto the surface of the water without breaking the skin. So, the paper clip is not truly floating, it is being held up with the surface tension of the water. The next experiment will be called lifting an ice cube.
We will be needing a salt,
a glass of water,
a thread,
and a piece of ice. Place an ice cube in the water. The ice cube will float. Then, lay the string across the ice cube in glass. Cover the ice cube with a string with a layer of salt. Then leave it for 1 minute. As you can see, the ice can now be lifted with just a thread.
Salt lowers the freezing point of water to below 0 degrees Celsius. When you added salt to the ice cube, the salt lowered the melting point of the ice. The salt is in a thin layer, so it melts a thin layer on top of the ice cube. The water cooled down further and reflows around the string. The next experiment will be inverted arrow.
The materials that we need is a glass of water
and an arrow diagram. As you can see, the arrow is facing the right side. And when you look through the water, the arrow is facing the left side.
When the arrow is moved to a particular distance behind the glass, it looks like it reversed itself. When light passes from one material to another, it can bend or refract. In the experiment, light traveled from the air, through the glass, through the water, through the back of the glass, and then back through the air before hitting the arrow. Light bends when it travels through different materials. To explain this, you must think about the glass of water as if it is a magnifying glass. When light goes through a magnifying glass, the light bends toward the center. The light all comes together, it's called the focal point. But beyond the focal point, the image appears to reverse, because the light rays that were bent past each other, the light that was on the right side is now on the left on the right. The last experiment is diffusion in water.
We are needing
a glass of warm water
and a glass of room temperature water
and some red colored food coloring
and also some green colored food coloring.
We will now pour the green colored food coloring into the room temperature water and the red colored food coloring into the warm water temperature, into the warm water. 1, 2, 3. As you can see, the red colored food coloring spits out faster in the warm water compared to the green colored food coloring which spits out in the room temperature water.
Warm water has more energy than cold water, which means that molecules in warm water move faster than molecules in cold water. The food coloring you add to the water is pushed around by the water molecules. Since the molecules in warm water move around faster, the food coloring spreads out quicker in the warm water than in the cold water. That's all from us. Thank you.
Thank you. Bye.
Bye.